Good morning friends. Now in this video we will try to understand some another basic concepts of machine learning. Machine learning and getting intelligence from big data. Here in machine learning we are trying to find out as much of data or rather data set as much we can, because by using data only we can take intelligent decisions and we can train rather the machine. Now, inside the machine learning, determining the right algorithm at the right learning model is important. Organizing machine learning operations into two broad subgroups. They are organized like local learning and remote learning. Now, in the IoT application, we know that there are edge nodes and fog nodes. There are sensors and there are gateways. Now, in the local learning, data is collected and processed locally, either in the sensor itself or in the gateway. So, this is called as the local learning, which is where the data is collected from the local location and the learning is happening. On the other hand, in the remote learning, we can see that data is collected and sent to the central computing unit, typically the data center or in the cloud where the data is processed, and from there the learning is happening. So in the machine learning, two types of learning are, or rather two operations are categorized in terms of learning. They are local and remote. Now regardless of the location where the data is getting processed, the common applications of machine learning for IoT are revolving around four major domains. So what we are trying to understand over here, that the machine learning applications for IoT. So with respect to IoT infrastructure, now we are focusing on ML applications. They are listed below and we will see them in detail. Monitoring. First application. Smart objects monitor the environment. So for what smart objects are available into our IoT infrastructure, they basically sense the data. They basically capture the data wherever they are operating. Data is processed to better understand the conditions. Like external factors such as depends on the sensor, can be a temperature sensor, humidity sensor of operations. ML can be used with monitoring to detect early failure conditions or to better evaluate the environment. So, mm, first of all, we are monitoring the scenario using the smart objects in the IoT. Second, behavior control. When a given set of parameters reach the target threshold or defined in advance, like supervised learning, or learn dynamically through the deviation from the mean value, means the unsupervised learning, monitoring functions generate an alarm. So in the behavior control, basically we are trying to control that particular environment. For example, in case of smart home, let's say you are entering inside the room, so you expect that automatically the lights and fan or air conditioner in terms of in summer days should get automatically on. So this is about the behavior control of that particular room, or otherwise you were supposed to do that particular thing manually. So it is like taking corrective actions based on the threshold. So this is the second application of machine learning uh, for IoT. Operations optimization. So operations optimization means taking the corrective actions. So analyzing the data can lead to the changes that improve the overall process. So here we are optimizing the operations. Optimizing the operations means we are making a control on the operations. We are rather, in terms of optimizing, we are making the analysis of the data, or we are taking some smart decisions on that, so that if based on the first IoT module, the another IoT module is dependent. So analyzing the data is an important thing. So for example, neural networks can combine multiple units like chemical, temperature, steering in one or several layers to estimate the best chemical steering mix for the target air temperature. And the another application of machine learning for IoT is self-healing and self-optimizing. Means what is happening over here is the scenarios are becoming automated. The infrastructures are getting automated. The practical domains are getting automated. Means they are behaving by themselves like a living organism. How does the living organism behaves? Based on the fact that whatever circumstances the organism or the person have faced, the person is taking the decision by themselves and then behaving properly and tackling that particular scenario. Here also, ML based monitoring triggers changes the machine behavior. The change is monitored and the operations optimization. The system is becoming self-learning and self-optimizing. It also detects new deviations that result in pre-detection of new potential defects, allowing the system to self-heal and self-optimize. So, a weather sensor provides the information about the local pollution level at the scale of the entire city, can monitor moving the pollution clouds, fog level, and the global and the local effects of mist or the humidity, pressure, and terrain, cloud level. All this information can be combined with the traffic data to globally regulate the traffic light patterns, reduce the emissions from the industrial pollution sources, or increase the density of the mass transit vehicles along with more affected access, ML and neural network. So these are some scenarios with respect to the current information that we are learning. Now predictive analysis. In the advanced stages models are network self-diagnose and self-optimize. Like it is the predictive analysis is one of the application where we are predicting what can happen, and based on that we are changing the current atmosphere. Like you can easily understand that uh, if we are making in the in the smart home, if we are monitoring the different rooms, so then we know that, for example, depends on the current atmospheric temperature, we are predicting that the temperature can be reduced or can be increased. So when the data from the multiple systems is combined and analyzed together, prediction can be made about the state of the system. So for example, transportation. So weight on each wheel, multiple engine parameters are measured and analyzed. Data processing center in the cloud can recreate a virtual twin of locomotive detected failures. Sensor values are combined with big data, can defects or issues in the vehicle operating in mines, in manufacturing machines in advance. So this is one of the example for predictive analysis.